So our agenda, I'm going to do two examples instead of one. And then it's just this Alex assignment and this exit ticket. I'm going to try and get those posted into Google Classroom here shortly. Maybe right after I do our examples, I'll post both of those in Google Classroom. But right now, the only place that you have a link to this exit ticket, which is just like warm up that we did a good while back. It's just checking to see how we're doing with this, getting rid of fraction stuff. So um, anyway, right now it's only in the slide. I'll try and get it into Google Classroom soon. Does anybody have any thoughts or questions right now? And Clarissa, I saw your thank you very much. And I'll check back with you about that a little later for sure. Okay, then let's switch it up to these two examples. All right, these are straight from Alex. And so just wanted to do a couple more. Hopefully it'll help us get more and more comfy with these particular types of word problems. So we see it's all about writing an equation in the form ax plus b equals c to solve a word problem. And let's just read through it and then we'll do some highlighting. Salma bought some books for $5 each and received a discount of $7 off her total purchase. She spent $58 after the discount. How many books did she buy? So the key pieces of information, if I go back and read it, is Salma bought some books for $5 each. I want to be really specific that this word right here, that's your best friend. And we'll talk about why a little more in just a moment. And then received a discount of $7 off. That also is, that word off is helpful, but probably not as amazing as the word each. Okay, so a discount of $7 off, and she spent $58 after the discount. All right, so there's three pieces of information. When we look at part A, it says, write an equation that could be used to answer the question above. First, choose the appropriate form, then fill in the blanks with the numbers 5, 7, and 58. Let B represent the number of books. So we already know that this B right here is how many books she bought. And what I wanted to say about this word each is when you see it, that's something that is happening again and again and again. And so every book she buys, you add another $5 on. $5 for the first book, plus $5 for the next book, plus $5 more for the next book. And of course, the shortcut for doing that is multiplication. So when you see each, what that tells you is this number that they're saying each with is going to go right in front of your variable. Okay, because 5 times the number of books, well, 5 times 3 books, that means she had to spend $15 more to get those 3 books. Okay, so each variable, just tell yourself that each, the number in front of the variable, also known as the coefficient of that variable. The other thing we got to figure out is which of these two equations is it? And because it's a discount, am I going to be adding this 7 on or taking that 7 off? Anybody? Everybody? I got my chat up. Nobody feels like putting in the chat. Anybody feel like unmuting and saying, hey, Mr. Reed, you're going to add or you're going to subtract? When you get a discount at the store, you don't know if you're making your price higher or lower. Really? Maybe nobody needs any help with this and we should just go on. Okay, then. All right, I'll get really mean. Hey, Mason, do you think we're going to add the discount on to the price or subtract it from the price? Malcolm, I need you to bully Mason so he can talk to me.
Malcolm, be quiet.
So are we going to add a discount onto the price or subtract it from the price?
Subtract.
No, Malcolm, be quiet. It's not your turn. Oh my gosh.
Thanks, Malcolm and Mason. I like that subtract answer. So we're definitely going with this guy.
Let's go, baby.
Oh my gosh, Malcolm.
We already talked about, since each book is $5, we're going to do the 5 times the number of books. And the discount was $7, discount of $7 off. So we subtract that. And it said after that discount, it was $58. So that's what we would have been filling in Alex. But I'm going to write it over here where we can see it a whole lot neater than that. So 5B, take away the $7 discount, equals a price of $58. Then we just got to solve that. I'm going to do it real quick. You guys are welcome to stop me and ask questions, but I'll just try and keep my mouth closed for the most part and see if I can come up with a good answer. All right, so apparently Sama bought 13 books. And if you don't believe that, or you're wondering, did I really get a right answer? Well, she had to pay $5 for each of those books. So we could say 5 times that 13 books. So that's supposed to be my dot for a time sign. Take away the $7 she got off of them. You could make sure that really does equal $58. Basically, what I just did is I plugged this answer into this equation, okay, to see if it works. Any questions there? If not, let's check out one more and then we'll quit. Maya's saving money to buy a bike. She has $42 and is going to save an additional $7 each week. The bike costs $133. In how many weeks will she save? Will she have enough money to buy the bike? All right, so if we do some highlighting here, she has $42 already, and she's going to save an additional $7 each week. The bike costs $133. So we're trying to figure out how many weeks will it take her? This is here, I'll just underline the question. In how many weeks will she have enough money to buy that bike? So the fact that it's asking how many weeks, that tells me my variable is going to be about weeks, a W. She's already got $42. She's going to save an additional $7 each week. If we're thinking about a savings account or the money in her desk drawer, whatever, what's going to happen with this $7 each week and the $42? If she's saving more, is that going to increase it? So I need a plus sign, or is that going to decrease it? Here's the decrease, a minus sign. Which one of those do I want, a plus or a minus? What you think, Clarissa? Clarissa. Are we going to add that $42 on to the $7 she saves each week, or subtract it from it? Thanks, Clarissa. Add is correct. So I'm going to plug these numbers in now. We have our favorite each right here, and that tells me that 7 is going in front of the W. $7 each week. So 7 times the number of weeks plus the $42 she already had. We need that to end up being the $133 it takes to buy the bike. So 7W plus 42 equals 133. Solving it real quick. Interesting, both answers happen to be 13. Maybe you should just always put 13 in for solving your equations in ALEKS. Not. If anybody wants to take a screenshot at the moment, I forgot to do that with the previous one, but we can go back up to it. But, I can, here's what, can't very well show it and have you do it at the same time, but you can screenshot it. I'll go ahead and screenshot it, and then I'm just going to paste it right over the top of the slide that Mr. Reed has in my week 13 slideshow. So maybe it'll help me remember a little something about what we just did. All right then. There we go. And so that's slide number 7, and the previous one is slide number 8. So that's just Mr. Reed saying, okay, now I can go right ahead and screenshot that one in. Does anybody need either of them any longer because you want to screenshot them into your slides? All right. Then I'll say, one other thing. Just an example, a reminder example of how we get fractions out of equations. So our original equation was just what's inside the parentheses there. There's 3/4 x plus 2 equals 2/5. And we have two fractions in this equation with different denominators. So that's what I'm dealing with over here, making a list of multiples of each one. So if I just start at the number 4 and add it onto itself, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. I stopped there because I knew for sure 4 times 5 is 20, so 20 is common to both of them. That's the same thing as saying, well, this is 4 times 1, 4 times 2, 4 times 3. However you want to think about it. And then the 5, I went down the list of multiples. The smallest number that is a multiple of both of them was that 20. And so that's why I'm multiplying the whole equation by 20. That means I multiply each term in the equation by 20. But when I did this multiply by 20 times the 3/4, that is what canceled out the divided by 4, because 20 divided by 4 became this 5 right here. That got rid of the 20 and the 4, just left me with the 5, but I had to remember I still have a 3x going on. So 5 times the 3x. And then this produced the 40. I did the same kind of thing here. 20 divided by 5 is where this 4 came from. But I couldn't forget that I still had a 2 left there. And so then I multiplied this to get 15, multiplied this to get 8. Now it's a basic two-step equation. Okay, just a quick reminder there of what we've learned. But so let's get out of this. I'm going to go back to our Google Slides real quick. And so this is our ALEKS assignment for today. It's got some of the same kind of problems, not all of them, but it's got the getting fractions out of equations problems in it, and it's got 3 word problems like what we just looked at in it. This right down here is a link to our video where we've done multiple examples of getting fractions out of the equation. Just a reminder about it. The nice thing about it is you don't have to listen to the whole thing. You can just scroll through it, find what it is, what kind of example you are trying to figure out, and then you can play it from there. So just take advantage of those as well. All right. The last thing is this exit ticket down here, and this is the link to it. I'll try and get it into Google Classroom here in the next couple of minutes. Any questions, guys? All right, we got almost 20 minutes of class left, so I'll give you breakout rooms, work hard, and ask all the questions that you need to.